So I think this worksheet is pretty okay. Same as last week's one, right? Still manageable. All right. So worksheet 19. Wait a minute. This is not the same. Just 1 second. Okay. And hide this slide. Okay. So last week, remember I did the graph with all of you, correct? And then I was scribbling. So I told you I will actually give you something that is nicer, neater, and this is the one. I can convert it to PDF later. If you want to take screenshot, you also can. But if I create the PDF, I think it will be sharper. So this is what happens when we heat substances. Okay, so this is what happens when we heat substances. You will see that temperature rises. Okay, and then it will come to a point where the substance, okay, starts to melt. All right, so we actually call this the, okay, over here, hold on, let me just indicate. Okay, so this is the melting point. All right, and during melting, okay, temperature stays the same. Why is that so? The explanation is here. Temperature remains constant. Heat energy gain was used to overcome attractive forces between particles. So some of the particles will move out of the fixed positions, right? And then they start sliding over each other, resulting in irregular arrangement. Okay, because it's some, okay? So these are referring to the liquid. So we are talking about liquid particles here. Majority will remain in the solid arrangement, okay, at the beginning. But as time passes, okay, you see more of the liquid state. And it will come to this particular point at point C, where the solid has completely melted into liquid. So if I continue heating this substance, okay, temperature will then rise again, all right, for this substance in the liquid state until it hits a particular temperature. We call this the boiling point. And this is where the liquid starts to boil, and then the liquid particles will be converted to gaseous particles. Okay, so what happens during boiling? Temperature remains the same, right? Why is that so? Explanation is here. Explanation very important in the assessment. Okay, so explanation very important. They will ask you, why does temperature remain constant, or how come there's continuous heating but the temperature doesn't go up when there was a change in state? You have to explain using this. I try to phrase it such that it's easy. Okay, so if you compare the two, right? I don't write it in different ways so that it's easier for those who prefer to memorize. Okay, so you see, I try to put it the same way. Temperature remain constant because heat energy was used to overcome the attractive forces between particles. But the second part, okay, second part is different. This is move out of fixed positions, right? Okay, that is because we start off with solid state. Solid particles are in fixed position. They are held together by strong forces of attraction. So during boiling, we have our liquid particles starting to move further apart. Okay, eventually they will start to move freely and rapidly in different direction. And that is where we get our gas forming. So throughout this whole section DE, we have liquid plus liquid plus gas existing together, okay, during boiling. When boiling is completed at point E, if let's say this is an enclosed container or this is an enclosure, the gas will continue to have a gain in the temperature if I keep heating it. All right, so I just explained to you about the change of states. All right, during melting and boiling, why is it that temperature remain constant? You have to explain this way. So far, so good. Can you understand this part? Okay, I hope this will be helpful to you. Right, so next week, then I'll give you another graph. Is the opposite. So what happens when temperature decreases? Then we have gas condensing to form liquid, right? And then liquid will then freeze to form solid. So what happens then? So the explanation will then be there for you on that piece of graph. Okay, so that's like a summary of the notes. All right. So quite important for you to keep this, because once you have this, right, you can use this for now. You can use it for next year, Sec 2. You will even use it in O-level exam also, because it's a popular question that's being asked all the time. Okay, so we have new student here today. Hello, how do I pronounce your name? Alphonse?
Yeah.
Alphonse, hi. Welcome to class. I will speak with you after the lesson. Hello, Chloe. Feeling better? You look like you just woke up. You took a nap, Wow. Lucky you. Okay. So I saw all of your responses. Okay, I think Kiran wasn't feeling well. So Kiran couldn't focus when she was doing her work, because I saw some errors there, and I got a bit concerned. But she explained to me. So now I know that she's not well. No wonder she couldn't answer like her usual way. Okay. So let's continue. Don't worry about, I have, made annotation. Later, I send you a PDF version. Okay. So this part here is like quick summary of the solid, liquid, and gas. Again, I'm going to tidy this up so it is clearer for you to see, but generally you should know about all the characteristics of the solid, liquid, and gas. You have the slides, correct, of the first lesson. Okay, I gave you the slides. This table is actually inside. These diagrams are also inside there. So you can refer once more. Okay, Ghazi, how are you today? Good? Yeah, but I don't see your work, you didn't do your worksheet.
I just did it, sorry.
Okay, you just did it. Okay, so later maybe I can download again. All right, so let's go on to our questions. Question 1. Okay, following shows heating curve of a substance. So heating curve, you will always see the temperature increasing. There'll be some parts where it stays the same, but generally it's an upward trend. So this is the heating curve. If it's the cooling curve, like condensation and freezing, is the opposite. You have the temperature coming downwards, all right, with time. So which of the following will show correct melting point and boiling point of the substance? I think this is just about graph reading. Okay, every one of you got this correct. Okay, so during a change of state, this is where we talk about either melting or boiling. So the first part here, this is where melting takes place. Every time you see a horizontal line in the temperature time graph, right? It should be the melting process, okay? Or the boiling process. Need to check the state that you start off with and end up with. Okay, so this tells you, okay, this is where not so accurate one. Okay. So you need to try to draw a line. Okay. Where you can read off the temperature easily. So melting point, because of the horizontal line here, stays the same for some time, right? This is the melting point. So it's 1,500 degrees. Boiling point in between 2,500 and 3,000. This is the only option, 2,800, even though it didn't really look like 2008 to me. It's like 2007 instead. Okay, but this is the closest. That's why we choose this as our answer, A. Question? Okay. All of you got it right. Only Kiran. I think Kiran not well. That's why she couldn't think properly also. This is the cooling curve. Like I mentioned just now, cooling curve is showing you how temperature change with time going downwards, right? So the temperature is going downwards in this manner. Which of the following statements are correct? Substance freezes at 80 degrees Celsius. Okay, it seems to be true. But maybe let me ask you, what do you think? All right, what do you think between A and B? This A is actually referring to this point here, in case you can't see it clearly or you are not sure. This is point B, point C, D, E, and F. So from A to B, what is the state of this substance? You can type in the chat. Okay, you can unmute yourself and tell me the answer.
Which one? For which part?
A, B. So from A to B,
Gas and liquid.
you guess that is a liquid? Not exactly.
Gas and liquid.
Gas and liquid. Harvard is right. Harvard say gas. Okay, this part here. You see, cooling, temperature goes down, right? All the time. Okay, so there is no change in state. Change in state is always represented by a horizontal line. Zishan? Ken? So this is a gas. Since you're not sure, you have to copy down Zishan. So from B to C, B to C is where you get the horizontal line. This is the part where you have gas and liquid existing together. Clear? Okay. How did you know that it's gas, Harvard? Maybe I can ask you this. How did you know?
Because when it's gas, it like condenses to a liquid and then into a solid. So you can see that on the graph.
See on the graph, you
can
saw
like
that
roughly
there.
see, yeah.
Okay, that means there are two changes in the states, right? You saw the horizontal line. Okay, good. Yeah. So this is how you can see it. All right. If you have two changes, right, that means very likely, because we only learn three states, right? Solid, liquid, gas. So if there are two changes, that means it has either got to be solid to liquid, liquid to gas. In this case, is cooling. Cooling curve. We are going the other direction. So gas changes to liquid and then liquid changes to solid. Okay, so we can actually somewhat guess it also. You can confirm later after you put it in. So from C to D, definitely this must be the liquid state, right? The whole range. Okay, so temperature goes down and down and down and down until point D, something happens. So what are the states here? Okay, because it's another change in the state, right? So definitely we already had the gas appearing right in the beginning. We cannot go back to gas again, because it's cooling curve. This must be freezing process. So liquid and solid existing together. Oops. And then lastly, okay, this is only solid. So far, okay? Chloe, can you understand? Yeah, good. Alphonse, you might be a little bit unsure because we are very much ahead, right, in the Sec 1 syllabus.
Yeah.
Okay, this is chapter 7. You are at chapter 4 in school?
Chapter 5.
Chapter 5, good. Yeah, around this time. Fair enough. Okay, so when we look at the statements now, I think it's a little bit easier, correct? So we talk about condensation here, where you have gas changing to liquid. So we have freezing here. Substance freezes at 80 degrees. This is correct. Quite clear, right?